Hi everyone, welcome to Persian Tech Network event in July. I'm Ahmad Reza Masroor, part of Persian Tech Network. As always, today we will start with two startup presentations and we'll follow the program with two fireside chat. First one with Rubil Ahmadi from NVIDIA and the second one with Mr. Ramin from AMD. Please follow us on LinkedIn, scan this QR code, and subscribe to YouTube channel. And let your friend know about the Persian community that we create here, and ask them to join us. Actually, we are here to learn from and support each other as a Iranian community in the Bay Area and across the globe. Anyway, now I'd like to invite the first startup presentation, which is Infinity Miles, and Siavash Sadeghi, the CEO and co-founder, will present his idea to us. Please join me in welcoming Siavash. Thank you. Not this one.
Hello everyone, my name is Siavash and very good. Hello everyone, my name is Siavash Sadeghi and I'm coming from Orange County, Irvine. I'm the sorry about that. And I'm the co-founder of Infinity Miles. My background is electrical engineering. I have PhD in power electronics from Georgia Tech. And my first time here, special thanks to Ahmad Reza for inviting me, originally from Isfahan, Iran. And I came to the United States in 2009 for my PhD at RPI. Unfortunately, I left the PhD after 2 years, joined General Motors, and after that, Capstone Turbine, Honeywell, Hyperloop, Hyundai. And in 2021, we established Infinity Miles to empower the future of mobility through our state-of-art medium voltage solid-state transformer to accelerate the transition to electric vehicle. The company is in St. Louis, Missouri, and let's get to that presentation. Doesn't go. All right, so the first market that we are looking at is the electric vehicle market. As you know, it's a $250 billion market with a growth rate of 23.5% until 2033. And especially on the DC fast charger, it's a higher growth market by 31% growth by 2032. All right, the current EV infrastructure charger is broken, in our opinion. You know, we have a few charging stations in US, but 32K for 2.4 million electric vehicles. The bottleneck for the conventional fast charger is the transformer. So if you want to order a transformer, it takes 2 years to get a transformer to step down the voltage and get to the electric vehicle side. Also limited power. Most of the fast charger in the market, they are in the range of 100, 150 kilowatt. Recently, I saw some of them around 350 kilowatt, but they are a few from EVgo. So it's putting a market over $30 billion to take, and we are planning to take that market. This is the current infrastructure of the conventional DC fast charger. So basically, we have power grid. From power grid, we have a low frequency step-down transformer, and we have conventional converter and the cabling, and then dispenser. So current infrastructure is expensive from the equipment standpoint, shipping standpoint, and laboring. Also has lower efficiency as compared to our technology, and we translate that one to the high OPEX. And then it's heavy. Only the transformer is around 6 tons. And the entire system is pretty heavy that, make it more challenging for the shipping company and installation. And also it's pretty large. Only the transformer is around 110 square feet for a 1 megawatt capacity. So with all these challenges and bottlenecks, we decided to establish Infinity Miles. Me and my friend in St. Louis established the company in 2021, and we started working on the solid-state transformer. This solid-state transformer is new. Some OEMs and some tech companies already started to work on this subject. In the past, it was not possible. The semiconductor switches were expensive, but currently the semiconductor switches are cheap, and there's no shortage on that, so it's available everywhere. So it makes the technology happen. This is our solution. So we are removing all the components from the middle of the conventional fast charger. So we are removing the transformer, we are removing the cabling, we are removing the converters, and we are just putting a single direct converter. So directly from medium voltage to the dispenser. By that, we are reducing the capital by 45%. We are increasing the efficiency by 3% to 96.5%. So we are reducing the OPEX on that. And then it's lighter. It's only a box. You don't deal with the transformer, with the shipping, with the laboring. It's just one package that you put it and just connect it from the grid to the car. So 75% lighter and 65% smaller. It's pretty modular, so we can use the technology everywhere. We can use it in US, we can use it in other countries with different input voltage level from 12 kilovolt to 18 kilovolt or 30 kilovolt. And the output is modular. You can have 10 output of 150 kilowatt. You can have 5 output of 300 kilowatt. So it's pretty modular. So with the Infinity Miles technology, the future of the EV infrastructure is going to be much simple. It's going to have a power grid, it's going to have Infinity Miles module, and then dispenser at the stations. Where we are, we already proved the technology. We built a small scale 9 kilowatt technology in 2022. We tested, we designed 1.5 megawatt unit, and this is one of the modules. So it is 50 kilowatt module. We are going to put 10 in parallel to make 500 kilowatt. We put 3 of those to make 1.5 megawatt. So we already built this one, and we are testing this module. We already have a facility in St. Louis 5,000 square feet space with 3 acres land with the advanced equipment inside. This is our product that we are working on that. We are trying to build a 1.5 megawatt unit. We are going to apply most of the standards, even in the A sample. And since we are already involved in some of those standards committees, so we know some of those features, so we are going to apply to our A sample unit. For that, the goal was building the 1.5 megawatt unit, but because of the high capital that we need at the beginning, we tried to build a 500 kilowatt, and then we basically duplicate that one, 500, 500, and 500. So for now, the design is 1.5 megawatt, but we are going to build 500 kilowatt and then duplicate that one. Talk about this one. This one. All right, so we are protecting our technology through patents and trade secrets. Our software control algorithm is going to remain as a trade secret. We have filed 3 patents so far, and we are drafting another 2 on the technology to secure the technology and the one. All right, who we are? It's me and Puria. Puria is in Missouri. I'm based in California, Orange County. Together we have more than 30 years of experience in the industry, and especially on the electric power and power electronics. All right, point of departure, we are looking for a pre-seed, 520K. I don't know if I can call it pre-seed because we already put our money and time to develop the 50 kilowatt module. But for building a 500 kilowatt module, we need 520K. 120K goes to the top tier team, 184K for the equipment and electronics, cost of 2 units, and we need 216K for working capital and also upgrading our testing setup to test the 500 kilowatt. So our timeline, I need to change that one to 500 kilowatt development unit timeline. Sorry about that. So we are looking at a 10 months timeline. If we start on July, we are going to have the 2 units completed by April 2025. Tested is going to be our A sample, and we are going to the B sample for the certification. Just to share with you some of our competitors, there are 2 that I know. Ampersand, they are based in Singapore. They already built a 1.5 megawatt unit last year, I think, and they already raised $70 million. The other company, Resilient Power, I think they are in Washington. They raised $5.5 million, and we haven't seen any product from them yet, and they are just in the development phase. We are not just looking at the charger market. It's a solid-state technology. It can be applicable to wherever we are using a transformer, right? So we are just replacing the huge and giant transformer with the solid-state technology. So solar market and wind energy market are the other markets that we are also looking at. Also data centers, they are using giant transformer for stepping down the voltage. So this is another area that also we are working on. I think that's it.
Thank you. Any question? Yes.
So you mentioned that you improved the OpEx, right? So have you considered the fact that this is electronic and no electronic lasts more than 5 years? Those transformers, they last for 50 years. We have to transform.
Yes. Yeah.
So is that nudged in already?
The point is, we translate that one to the efficiency and power consumption that we are basically having, and energy consumption. But definitely you are right. So those transformers are going to last, I don't know, 100 years probably. But electronics, for sure. The electronics, I think 20 years, we can say 20 years or something like that.
Do you have any active cooling for those things?
Yes. These are basically submerged in the oil. The entire switches are going to be submerged in the oil. Yeah. One of our patents are on the packaging side, yes.
Thank you.
Any other question? Yes, last question.
Thank you. So who are the specific customers of this product? Is it going to be the EV charger manufacturers or electricity provider companies in states? Like, or have you identified like specific?
Yeah, that's a good question. So as I said, our first target is the charging company. Let's say ChargePoint, EVgo, those that they are active on the fast charging infrastructure. They can just replace the current design that they have with this technology, or wherever we are using a transformer, let's say the substation. When we have a substation and a step-down transformer, we can use that one. Yeah. Wind, solar, in the solar farms, they already have a huge transformer. They can just replace that one with the solid-state transformer.
Thank you,
All right.
Sebastian.
Thank
Thank you. Give him a
Thank
round
you.
of applause. Thank you. So the next startup who is presenting over Zoom is Bitsy. Babak, the CTO and co-founder, will present. Please give him a round of applause.
Thank you, everyone. I'm Rubil Ahmadi, based in Montreal, Canada. Tonight I'm here. I'm a co-founder and CTO of Bitsy. Tonight I'm here with Walter, our CEO. We are presenting our startup with you, and hopefully we can get good feedbacks from you. Walter can start presenting the portion of the idea, and then I'll continue and follow on that.
Okay, great. Thanks, Babak. I'd just like to also mention that we have 4 co-founders of Bitsy. Dr. Greenwald, which is an individual from India, and he has a doctorate in veterinary medicine. And then also Hamed Shamadi, who is also of Persian descent. So we started the company in 2021, and the idea and thought was really to address the problem that we've identified in the veterinary industry around pet care. Each veterinarian clinic around the world and country in the US uses a software business solution called PIMS, Patient Information Management Systems. And those systems are complicated, expensive. They lack customer engagement capability. And one of the pain points that we got from our research with clinics, the PIMS system results in them having a resource issue and time issue. So it really is a hamper to their overall business. In addition, we did a lot of research around pet owners. And one of the main things the pain points from pet owners that we found is they're looking for one website that they can go to take care of all of their pet needs. And that includes making an appointment with the veterinarian, communicating with the veterinarian, as well as getting all of the items that they need to take care of their pets. As we look at the pet market, it's a pretty huge market. If we look at just the US PIMS market, we estimate that to be about 1.2 billion. But the annual spend on pets in the US is 136.8 billion, and that's just the US. That market will continue to grow over the next 5 to 10 years. So we feel that the market size is going to continue to increase. As we look at the annual spend for pet owners, dog owners will spend on an average of $1,400 a year on their pet, and cat owners almost $1,000 just for their pets. One of the things that we're looking to do with a Bitsy platform is really to provide a single place for all of your pet needs. And that's communicating with the doctors, communicating with the clinics, pet clinics, but also the ability to purchase all of your pet needs online within Bitsy. So from a value proposition, we are really going to start by focusing on veterinarian clinics. And we are designing a PIM system that is all comprehensive. And I'll let Babak talk a little about our PIM system.
Thank you, Walter. Thank you, Walter. Yes. So the Bitsy PIMS is a comprehensive system that provides a day-to-day features that clinics they need on their day-to-day jobs, right? So it includes different modules like customer engagement, inventory management, appointment scheduling, invoicing, and reporting. So it's a very complex system, and we are trying to build a system that automates a lot of steps in the clinics, that it makes it easier for a staff to interact with the PIM software, that leads to customer efficiency and operational efficiency. Actually, what is the key features that it differentiate us with the other PIMs in the market is one of them is cost effectiveness. So we are leveraging a serverless technology to build our infrastructure, which is cloud-based, is highly available, is scalable, and is very secure. Also, very intuitive and user-friendly. It is compared to the other PIMs in the market, based on the feedbacks we received from the test phases we ran. So the user feedbacks was it is very user friendly, very easy to navigate through the different complex flow within the PIMs, and is very intuitive. Also, we are leveraging AI technology, some advanced AI features in our PIMs in order to make the day-to-day work of the clinic staff easier, because the staff in the clinics, they have a lot of load. By leveraging the AI feature, we are trying to give them more time that increase their customer satisfaction and also operational efficiency. So some of the AI feature that we are offering in the PIMS, in our Bitsy PIMS, is a virtual assistant agent. So what it does, actually, the staff of the clinic, because the PIMS by itself is very complex system. It has very complicated workflow, from inventory management, from patient history documentation, from patient management, appointment scheduling, invoicing, automated invoicing. So one of the AI feature we are offering is a virtual assistant agent. So basically, staff of the clinic, instead of directly going through the complex workflow within the PIMS, they can communicate over voice with an agent that is built in the software, and that agent can take care of the job and they need. It will take care of the interaction with the system. Let's say if over the voice they want to document the patient history, they can just talk to that agent, and agent can create a standard clinical documentation, which is standard. It has to follow some certain standard, but that agent can do the job for them. Also, if they want to navigate through all the different part of the software, they can also by voice communicate with that agent, so that agent can navigate the user through all the different part of the software. Also, we are implementing a predictive analysis for inventory management, leveraging ML machine learning. So basically, what we are offering is with that advanced AI feature, that allows the clinic to manage the inventory in a smart way. So it prevents the clinics to overstocking or stock outs. Also, it forecasts the supply need for the clinics so they can better invest and spend their money on buying supply for the clinics. That ultimately leads to lower cost of inventory management and prevent of the loss. Like, so one of the biggest pain point that we are hearing from the clinics are the loss of the items, like for instance, like expiration of the medical items. So these medical items, they are, when they expired, actually they are losing money on that, and they don't know when, how much money they have to spend, when to buy, and how much to buy of that specific supply. But with this predictive analytics AI feature, it can help clinics to, in a smart way, to invest their money to buy supply for the clinic. Also, with the leverage of the data we have in the Bitsy PIMS, we are providing a business intelligence dashboard. This dashboard, this is an example of the dashboard. The Bitsy PIMS is the only PIMS in the market that provides this intelligence dashboard. It provides a real-time insight and also shows key performance metrics of the clinics. So it can give an idea to the clinics what are the trends, what are the issues, what are the underlying issues, abnormalities. So it can also give them predictive analysis on appointment scheduling. So they can have a visibility, the clinics, they can have the visibility of their performance. For instance, in the appointment overview, they can see the number of visits, the key performance metrics. They can also see the financial performance. This is very smart, interactive dashboard that only PIMS offer within the Bitsy PIMS software. And then I guess, Walter, you can continue on that.
Yeah, so I'll talk a little bit about where we are with the development of the PIMS, and we've kind of established it in 3 steps. One, first step, we expect to complete the PIMS in Q3 24, which is the basic features to really compete into the market. And we plan to launch the PIMS system into the market by Q4 2024. In addition, in step 2, it's really all about enhancing the features that we ultimately need to get to really have state-of-the-art PIM system, and we plan to complete that by Q2 25, as well as enhancing AI and machine learning features is a continuous process, but we think we can get the bulk of all the elements done by Q3 25. So that's where we are from a PIM system. But the Bitsy business model is a 2-sided model. The first side is to drive revenue through selling Bitsy PIMS into the veterinarian clinics. Each pet owner will get a free membership to Bitsy so that they can go on to Bitsy and make appointments and communicate with their veterinarians. So what we understand is that pet owners are looking for one place to really go for all of their pet needs. So the second phase of the business to drive additional revenue is really online retail that focus specifically against those pet owners. One clinic will bring to Bitsy around 3,000 to 5,000 pet owners. We estimate within the first 5 years, we'll get Bitsy into 3,000 clinics. That translates to 9.1 million pet owners that we have a captured audience in order to sell pet products to them online. Being a marketing expert, I know the conversion rate for general marketing to consumers is around 3 to 5%. When you have a captured audience like we will have for these pet owners and being promoted by the veterinarian clinics and the vets themselves, our conversion rate for pet owners to purchase online with Bitsy increases from 4% up to 25%. So we feel it's a great opportunity to really maximize.
Walter, you have 1 minute.
Okay, this is the last slide. 5-year projection, we think we will pretty much break even in year 2, and by year 5, deliver 74 million in revenue with 15 million in EBITDA. And that's pretty much it. Our ask is 500,000. 40% of that will go to continued software development and 60% to marketing and sales. We just like to thank you guys very much for giving us the opportunity to present to you. And if you have any questions, we'd love to take them on.
Thank you, Walter. Thank you, Babak.
Thank you.
Any question? We have one.
So my question for you guys is, since you want to make a one-stop shop for all pet needs, then are you integrating this system with pet insurance as well? Is that going to be a platform for pet insurance to be completely integrated into your entire procedure?
The answer to that is yes. With regards to selling pet insurance online, there are some regulations that you have to deal with regards to being able to be an agent for insurance, and we're working through those regulatory concerns. But the answer is yes. Pet insurance is going to be one of the key features that we offer online to pet owners as well.
Any other question? Thank you, Babak. Thank you, Walter. Give him.
Thank you,
Thank
everyone.
you guys very much.
Thank you. Now, I know that you are super excited to hear our speaker's journey tonight. Without any further ado, I'd like to invite Saeed, our great moderator tonight, to come up and run the fireside chat. Thank you.
Hello. Oh, it works. Good evening. My name is Saeed Nesbat, and I have the pleasure of running the fireside chat section of the meeting tonight. But before we get to that, a couple of preliminaries. I've been told to encourage you to use that QR code to go to whatever site it is, but I think it's LinkedIn, to subscribe to it. Also, I've been told to ask you to go to youtube.com and look for Persian Tech Network, Persian Tech Network, and subscribe there. I know the reception here in this hall is a little bit less than what it need to be, but when you get home, please do that. And if you do that next week when you come in, next month when you come in, you will be entitled to extra pepperoni pizza over here, so don't forget that. The other thing I would like to mention, like always I say that, please remember why you're here. You're here in order to make connections. That's how we make our community, our technical community, strong. So please, please talk to strangers, go introduce yourself, ask about them, be nosy about what they do. That way we can develop the Rolodex in your brains about who is doing what. We're striving to make it a very close-knit community with everybody knowing about everybody else. And now about the program. I need 3 hands for this. I am very excited about the program we have tonight, because tonight we delve into one of the hottest and most competitive areas in hardware technology. Usually we talk about software over here or biotech, but tonight is devoted to hardware. And that technology is general purpose GPU, which is used in AI, crypto functions, molecular dynamics, and physics simulations. Admittedly, NVIDIA has long been the dominant force driving innovations and revolutionizing GPU computing. However, competition is fierce, and AMD is emerging as a formidable challenger, striving to dislodge NVIDIA from its top position. So tonight, we'll duke it out. Tonight, we'll explore how NVIDIA can maintain its leadership and what AMD needs to do to challenge that dominance. Our discussion promises to be insightful and thought-provoking as we hear from two leading authorities from these two companies. First, we are privileged to have Mr. Rubil Ahmadi, Senior Chip Architect from NVIDIA, with us tonight. Rubil has been contributing to cutting-edge solutions that have set industry standards and propelled NVIDIA to its leadership position. Please join me in welcoming Rubil Ahmadi to the stage. Can we have an extra mic, please? Yes. My mic is working? Okay, good. And let me fix my...
Yeah, me too. I think I got it fixed.
No, I think we have to deal with it all night. Bear with me. Okay, is yours, what is it? The chairs have problems, yeah, it's a Zamin catch, yes. Okay. Rubil Ahmadi, welcome to Persian Tech Network Fireside Chat.
Thank you for having me, Saeed.
It's a pleasure and an honor to have you. You worked at NVIDIA for almost 13 years with a one-year break that you took to tend to your startup adventure.
Yeah.
Which is Wave Health?
Wave Health, yeah.
You also worked at Synopsys and AMD. But before all that, let's go to the beginning. Were you born in Iran?
Yes.
And did you go to school there?
Yeah, so I was born in 1977, if you are interested to know how old I am. And then in 95, I joined Sharif University for EE major. And around 2000, I got graduated. And as most of you know, like military service is the hurdle for guys to get out of the country. So I had to stay in school for an extra year. And then in 2001, I went to Toronto for my master's degree.
But hold on. We missed the question. There are two things I want to ask you. One of them is, were you born and raised in Tehran? Or
No, I am from Kerman originally.
Anybody from Kerman over here? Not
There you
everybody
go.
is from Isfahan, as we.
Yeah. Sorry I disappointed you. I'm not from Isfahan.
No, it's a pure pleasure. Also, we usually ask people about their concours ranking. What was your ranking?
81.
81, not too shabby. And then you went to Toronto.
Yes. 2021, 2001, I went to Toronto for my master, and by chance or by, I don't know what, I started working on EDA, so I was destined somehow to work for a company like Synopsys or Cadence, but I had a thing for transistors all along, so after I finished my master's, I joined ATI, and as you know, ATI had headquarters in Toronto, so most of the graduates, they usually join ATI. And
whom did you work with at university?
Farid Najm, he's a Lebanese professor from Illinois, and he was like almost as good as my father to me. He was a great guy.
Also, he is an authority in high-speed circuit design and a
Yes.
fellow of IEEE.
Yeah, he's a fellow, and he's a great guy. He's a very known guy for power analysis and all those kind of stuff.
So you started in EDA, then moved to hardware design. What made you go to hardware design? You
Again,
said a thing you had about transistors.
Yeah, I don't
How
know
did that
if
come
people,
about?
here you go. Like people who are here from Sharif, they know Sharif Bakhtiyar, you know, Dr. Alavi, and all those people. They plant the seed so strong that your heart is always beating for electronic. With all due respect to, architecture and all those stuff, I don't know, they did something to us. They implanted something that always I wanted to do transistor.
So you
right?
were a bottom-up person.
Yeah.
Yes,
yeah,
as far as the
always.
architecture.
Yeah. So having that love, so I couldn't stop it, right? So even though that I studied EDA and wrote code and all those stuff, I started transistor design. And I went back to what I like to do, and with sometimes you have maneuver like hurdles a little bit because they hire you for something, you say, oh, I'm not happy, you take extra course to prove that I can do it, and eventually you land somewhere that you want to do. And in ATI, I joined the mixed signal team working on PLL, DLL, mixed signal stuff. I can tell for most of my career I have been on I/O side, right?
So timing issues.
You name it, yeah.
So that's what make the chip work, actually. I want to take a few minutes because a lot of people over here have aspirations of starting their own company, and you ventured into that. You took a year off and did Wave.
Yeah, fast forward, I moved to US in 2011, and I joined NVIDIA. And once you come here, you get that bug that I have to work for startup or start a startup and all this kind of stuff. And I had to get that bug out of me. So in 2015, April 2015, a good friend of mine from Sharif too, who has been in Stanford for 10 years working on ultrasound, he raised some money.
His name?
Amin Nikuzad. Amin raised some money, started Wave Health, and I was #1 to join his venture.
And what did the Wave do?
Wave, they are still continuing. We made portable ultrasound. So the whole point was to make a kind of like over-the-counter in your bathroom countertop device that you can scan and you can see your guts on your thing, which basically is for, mainly it was supposed to be for pregnant moms, but you know, like going through FDA, of course you have to pivot, and that was the great learning. So during that year that I was working for Wave, you know, I'm a transistor level guy who all I knew was like transistor in the ASIC. I had to write, I don't know, Wi-Fi driver, kernel, driver, and all.
You had to do everything like a typical startup.
Everything,
yeah.
which is beautiful, right? Like that's the pleasure of working for.
So what happened after 1 year?
So after 1 year,
You had a foot in NVIDIA. I think I was tempting to go back.
Yeah, so that was the beginning of NVIDIA pickup in 2016. And to be honest with you, it was, I found that, you know, I'm an engineer nerd, right? So I was part of like developing this stuff and everything's working, but as soon as you see the hurdle of, you know, FDA approval and all this stuff, how to make money out of it, it wasn't me, to be honest with you.
That wasn't interesting for you anymore.
No,
yeah.
no, I'm an engineer and I love.
Good point for those people who want to delve into a company.
Yeah.
You have to do everything, and some of the things, some of the activities may not be what you're
Absolutely.
starting.
And I highly recommend, if you have that bug, get it out of your thing, and then you settle down to what you have to do. If I had that bug with me all along, I couldn't be happy in where I am. I'm super happy in NVIDIA now just because of a year that I left.
Very good. That's good advice. Now let's focus on NVIDIA and its stellar rise as the most powerful hardware technology company of our times. It is right now. You've spent about a decade and a half at NVIDIA, seeing the recent ups and downs there. Arguably, the biggest turnaround success of NVIDIA started in late 2006 with the introduction of CUDA, which allowed GPUs to be used for general purpose parallel programming as opposed to just graphics. This followed by NVIDIA's expansion to support AI and data centers in 2010, the introduction of Kepler GPU architecture in 2012, and Pascal in 2016, all very successful projects, and the rise of deep learning and AI in 2015. But perhaps the single most important event that started the recent AI revolution was when AlexNet won ImageNet, ILS VRC, Large Language Visual Recognition Challenge. And that happened on September 30th, 2012. So that was a big inflection point. Please tell us the significance of this event for NVIDIA's rise.
As you said, we planted the seed. I mean, NVIDIA, I was not part of NVIDIA back then, but way before that, when even CUDA started, As you may know, U of T, University of Toronto, is really good in graphic, right? Like most of the hires from Pixar, Pixar's hire are from U of T. So NVIDIA used to go there, have lots of presentation, introduce them to CUDA, how to use CUDA, and also give them like free GPU, right, to use for graphic. Then Jeff Hefton in 2012, if they had AMD GPU or Intel CPUs, right, most probably they would have trained it on that. They had free hardware and they tried it. Of course, like they wanted to have like the CUDA and all the practices to be able to train, but that was the point, the inflecting point, as Saeed said, when they found, hey, GPU is good for the math that has been around since 1950, and they used it, and that was when I believe even Jensen started to say, that's what it is, and we spend lots of money.
Jensen Huang, the CEO.
The CEO.
Yeah.
Yeah, and we started, like, I would say the major investment that we started in 2012, right, when we developed new CUDA. New CUDA started, is the layer above CUDA, and then Digit, and all this like training stuff started back then. But what people start seeing was 2008, 16. But if I want to say like where virtualization came really to hardware was 2012 in Kepler.
Mm.
Did I answer your question, Saeed?
Yes, but I have more.
Well, sure.
When you said Jeffrey, you meant Alex, Ilya, and Jeffrey, the three-team person who did the winning, the amazing winning. Also, what is CUDA? If you can explain in a couple of sentences for those people.
CUDA is the layer on above driver that gives you the capability to use GPU as a calculator, if I want to simplify it, right? So you have a GPU which is capable of doing lots of math for you. You can use that math to render a picture or shader and this kind of stuff.
Or do other parallel processing, yeah.
Or do other parallel processing. CUDA gives you that capability. Literally, if you look at CUDA as an API, it has a matrix manipulation APIs, right?
So it's a software layer that sits between your Unix or whatever programming system that you have and the actual hardware, so you can use it efficiently.
Between that is the driver that basically says that that's my instruction set, that's how you use it. So equivalent of CUDA is OpenGL, which
with the emphasis on open.
Open, yeah. So I don't know if it's a benefit, but the way that I look at like CUDA versus OpenGL is the way that we look at Windows plus like Intel versus Apple, its own hardware. You know, like once you have control over your software, when it's not open, you have a very tight control. You know what you want, and you don't want anybody to touch it, right? It's exactly, look at it as Apple infrastructure, how they don't want anybody to touch their hardware, software tightness.
Keeps the riffraffs away. Also the competition.
The competition, yes. Yeah.
Let's talk about some of the issues that may threaten NVIDIA's dominance. I know a lot of people are in this room who blame themselves that they did not buy NVIDIA stocks when it was like 2 years ago, 3 years ago. How many times has it come up?
This one, like the waves like this, steps that went up. I would say 4 or 5 times.
4 or 5 times at least for the past 2 years. But there are dangers in being the leader.
Absolutely.
And you know,
every high has a low. We know, even Jensen knows, everybody knows that, you know, we would not stay.
Okay, so let's discuss some of these things that can expedite those lows. One of them is intense competition.
Yeah.
Intel, Google's TPU, Tensor Processing Unit, and AMD are investing heavily in AI hardware and are willing to conduct a price war.
Yeah.
So if they undersell you, if they provide you something which is flexible, not closed like CUDA, and they can get some alliance of people to go with them. How do you counter that? How do you think NVIDIA would counter that?
The first thing is the head start that we have, I believe, usually, like TPU came up Google came up with TPU, and they had, I can't say like they have good product because they know how to, what they need to design for. TPU is really good for their own TensorFlow because they know what they need, and they, in Harvard, they implement exactly that one. But what gives us the privilege is the software stack that we have. We don't just make hardware, right? I know you asked, Said, what could take that crown from us? The only thing that I can say is if there is a fierce competition that they really work hard to reduce the gap, we are almost one generation ahead of everybody, right? So what people usually make and they come and they compare it against is the previous generation of NVIDIA. It's not the first one. So always we are one step ahead of them. The only thing that at this point, I know I'm cocky saying that, is if we become cocky and we lose that edge, right? We become lazy not to maintain that one generation gap that we have right now, and we lose it. Because we are also working super hard, working with our customers to make sure to understand what they need, and we make that one happen for the next generation. One example that I can make right now is when you scale to that extent, reliability of this system becomes like the very, very important aspect.
Very
right?
crucial, yeah.
Time between failure, especially like these models run for months, you cannot bring down the system because you want to retire or replace a thing. So everything has to work constantly without any error. When you scale up, like when you connect two GPUs, if one of them come down, it doesn't matter, right? But for a 3,000 GPU, the probability of the whole system to come down, like something happens, is very high. So we are working, for example, I use that one as an example that we are fiercely working on this kind of stuff to stay ahead and not lose what the market is demanding from us. But I don't know, like, I didn't answer your question.
Yeah,
what is the notch to kill us? I would say if we become lazy and not work hard.
And among the competitors we named, or maybe some of them we don't know, who do you think is the most to be feared? I hope AMD.
No, AMD, again, like I work for AMD, I love ATI, and still I was telling Saeed that every time that they have a new announcement, I want them to be good. But
you're rooting for the home team when you were there.
Yeah, why not, right? Like competition is good. It makes the market healthy, right?
Yes.
So that makes us to make a better product. Literally, we shoot ourselves in leg by introducing a new generation because the previous one becomes useless, right? Yes.
But the new generation Blackwell, do we know how much the pricing is going to be? 50,000, 60,000?
A lot, but you have to see how beautiful that one is. No, honestly, it's a piece of art because of the addition. I worked. People say, tell me like if I'm going off road, right? Because we bought Mellanox.
We go together if we do, yes.
We bought Mellanox in 2019. Everybody was frowning at us. Oh, like in a GPU company, what do you need a networking company? And that's the offspring of that marriage, right? Like we took in the networking stuff. Now our GPU connects to like kind of infinity switch directly because NVLink for data link layer language is infinity, so we can speak to those. And the way that we can scale, you have to watch Jensen's Computex conference keynote. So like that's how it builds up. Two die on one board, they connect to each other. It makes it like GPU. We have a Grace down there, and then we connect them multiple board together with NVLink switch, and then connects it, and we make such a rack of all on copper, meaning like all the interconnects are connected through copper up to this point. And from that point, we use this Mellanox switch to connect them through fiber. So we have a data center that you can look at it as one GPU containing like more than 3,000 GPU. That's the beauty of what we are doing with Mellanox and where we are with Blackwell, you said.
Mm-hmm.
Blackwell is capable of scaling to that extent. And that's why it's expensive.
And you haven't told me who's the fiercest competitor that you're afraid of.
I would say AMD, and
Good
Intel
answer.
is doing good stuff.
You're not worried about Google?
with all the respect that I have, they are not ASIC company.
They're not?
They are not ASIC company, so they can't make chips, right? Like they came up with something. Their success story is they knew what they need. They made exactly that one. They are a great. They are great at software. So that one trickled down, and they have a good TPU. It works, yeah. But is it a good power? Does it have a good reliability? Do they know how to scale? They have a great product, but maybe for themselves, right? I'm not that worried about Google or companies that they are not AC company. If I say somebody can catch up, with all the respect that I have for AMD, Intel is doing great stuff, but if you remember, they bought Nirvana to do something on that one, didn't get somewhere. So I don't know if they are starting from scratch, but I don't know if, because I like AMD, I would say AMD, but I would say AMD is doing great stuff, especially with the good leadership that they have. Honestly, they have great leadership.
Another danger may come from a change of paradigm, like something in the use of tensor or some similar chip becomes so ubiquitous and practical in terms of power performance that blindsides the companies like yours.
Yeah, yeah. Again, like if you lose the sight, yeah, definitely. It's interesting enough, we have like internal reviews and we go through companies, especially like startups, and see who is becoming somebody, right? Like that we have to be worried about, right? There are companies out there, they're hardware-wise, they are becoming good. But again, one thing, we are not just a hardware company. For every, I would say, don't quote me on this number, but maybe for every hardware designer, we have 3 software designers, right? So we have a lot of software behind what we sell as hardware. It's not hardware, we sell system, right? So we give the capability to everybody that, you know, you buy this piece of hardware, we are behind you in terms of telemetry, controlling this stuff, I don't know, how you manage your workload, everything. There are tons of companies, they came and they are gone already. I want to make an example of what was the Compute Wave? Oh yeah, Compute Wave. They came out, they had a great hardware, right? Like it was capable of doing stuff at low power and all this stuff, but it was a gigantic calculator. You can't do anything with it, right? Like, can you train and use it as something like you give it a piece of code and you really utilize all those like hardware and parallel hardware underneath. That's the magic of like AI, and you can't just sell hardware. You may find a good hardware company, but unless they have a good software and the entire stack to make it usable. Every time that we have a new generation and we introduce new instruction set, we have dedicated team. They go through old compilers, every piece of like crappy old codes, make sure that those guys through our software layer can use those new infrastructures and the new instruction sets, and our hardware is used, truly is used, right? For not one guy, not one new compiler, for everybody, right? These are, I would say, the differentiator between but yeah, like if a startup is fast, and you said like if you get blindsided, we are very careful not to.
My last question before I open to the audience for asking questions. Do you think power is going to be of any issue? Power,
oh, it is.
It is already.
It's already, yeah.
For the world, that is right now.
World, it is like still when
and you're contributing to it. You're not solving it.
So you mean like power consumption, right?
Yeah.
Yeah.
I mean, if everybody wants to use AI,
Absolutely.
and it's all over the place on the edge in data centers and all that, they predict that 20% more power, and we are going to hit 1.5 degrees.
No, it is. It is. Power isn't an issue. One of the reasons that we don't like maybe Bitcoin and cryptocurrency and all this stuff is the power consumption, right? Mm-hmm. It's a good alternative to fiat currency, but it takes too much power. The same thing on this one. No, we are actively looking at the power, even though when you go to this high-end stuff, we use, liquid cooling and all this stuff. Usually when you are making this cheap, budget is not the goal, not budget. Actually, budget and power is not the goal. Performance is the one. So we have once we design a high-end, like, I don't know, 100 series GPUs, we have the blank check for area, you know, and we usually break the radical limit of the die. And power is not an issue because we have money. I mean, whoever buys that has the money and infrastructure to cool them down. But definitely we consider power when we are designing, and usually the next generation we go and revisit the power consumption, all this stuff that.
Thank you. Now I would like to ask you to think of some questions, and we have some hands raised over there. The first gentleman on the, do we have a mic, or should I use this mic? I use this one. Please mention your affiliation and your name first.
Yeah, my name is Ahsan Habib. I'm just visiting here. Question. So there's a lot of investment went in the chip side, like Samba Nova, Grok, and all this thing. How do you view them? And do you see them building products that can be successful?
Definitely, you mentioned like good companies, right? They have great, because like they are great people who started those kind of Grok and SIGGRAPH and hardware-wise, honestly, everybody can make, I don't want to say like everybody can make a good piece of hardware. If somebody can make good system, again, I would say NVIDIA should be worried about. It takes a lot to get to the point that you make a good hardware and use it, right? But no, there are good examples, and you know, as long as we don't miss those, NVIDIA doesn't miss those companies, we have an eye on them to make sure that they do not get ahead.
Reza?
Yes, hello.
Hi.
My name is Reza Muqtadiri. I have an AI calling company called Fonello. My question is, NVIDIA is talking a lot about this concept of token factory and basically turning many, many jobs and businesses and processes into token production. And as a result, the idea is that many data centers have to now change from traditional CPU-like architectures to more GPU-like architectures. You being an ASIC engineer, what is your thought on how that transition is going to happen across thousands or millions of data centers that are all over the world? And I also want to tack on to that question, if that is the case, if token production is the future, and we think that this transformer architecture is now leading that, is standing or staying on GPU still the best way, or is focusing on more ASICs and hardware that is optimized for those type of transformers is the better way?
It depends. Like, I'll answer the last question. Is it, if I want to rephrase what you said, is GPU general purpose enough to serve everything, or no, we have to go to our more like specific ASIC tailored for some stuff? There are some companies that they are doing that. They are focusing on, they're saying, I don't want to make a GPU. I had an example that D-Matrix, right? They are narrowing down they are focusing on, okay, just for training, I don't need all these branching features that we have in GPU and bright prediction and all this stuff, because I don't need it. I want to just do the calculation and do all those kind of stuff. That's what TPU is, right? Do we all go toward that? My prediction is no, because it's not just training. Interesting enough that even our high-end GPU, we have multiple variation. We have some stuff that is just for training, but we have stuff that still is good, not necessarily for AI, for other high HPCs too, right? Because they are not the same nature. So my prediction is that GPU as what we define today will not go away and will be replaced by very specific ASIC thing, right? Now I want to go back to your first question is that you asked, how do we transition from all CPU data centers to like GPU? It should happen organically, right? Once you see that, you know, it's like demand, right? Like demand says that we need more GPU, data centers are, and now companies like those like data centers, what do they buy? CPU or GPU? Yeah, we still need a CPU, right, to manage all this stuff, because GPU standalone is just, again, it's a big ALU, so it just has lots of computation, but still you need an OS to run all those stuff. So CPU is not something that is going to go away completely, but the transition, and I think it's the kind of sweet spot, somewhere that how many CPU do I need for n number of GPU? And it lands there. And I believe the demand dictates that. It's not going to be like we sleep tonight and tomorrow everything will be GPU, all GPU, or whatever that is supposed to be. It organically, my prediction is organically will go there. The same thing that has happened since 2001. You know, when this ChatGPT came up, now everybody, you know, ChatGPT 1, 2, 3, 4, now 4 is out, more training, more power, so we want it.
We have time just for one more question.
Yes. Hello, Rubil. Thank you very much for this wonderful panel. So I have a question: is
your
just
name and your affiliation?
Oh
please?
yeah, sorry.
Yes.
My name is Ralph. I have a startup company in robotics. So Jensen Huang made a kind of presentation like one month back. He put all the 10 humanoid robots, and it was in the middle, and it was after that they beat the Apple wins market valuation. So Ryzen, the second biggest company in the world. So the question is, what is his mind? Is what is the NVIDIA is trying to lean to the robotics? What they want to do with the robots? They want to provide like high GPUs or CPUs for the brain of the robot, or they want to build their own robots? So what is the vision of NVIDIA to lean this robotic industry?
Yeah, it's like inferencing, because as you know, we are not just in GPU, we have an SoC too, right? So we have a very powerful GPU that is paired with ARM CPU that we develop ourselves. We have one of that version as a big server that we use, like we call it like Grace CPU that is paired with GPU now, and we have the smaller version of that SoC that is being used for robotaxi, robotic, and you name it, autonomous driving. We are in that business, and the vision is, if you call it like inferencing side of AI, still GPU is used, but not as powerful of the GPUs that are being used for that purpose. And if you want to call it like edge computing, these SoCs are used for edge computing and inferencing. And I would say that at the end of the AI link, right? You train, you use it somewhere. And autonomous is a good example, right? We sell chip to car companies. Lamborghini has our chip in it.
Very good. Well, thank you very much. On behalf of the Ahmadi Group, the Persian Tech Network, the Plug and Play Company, and the Persian community, I thank you for spending the time with us and enlightening us about these issues.
Thanks, Saeed, for having me.
Thank you. Next, we welcome Ramin Rohani, Vice President at AMD, in charge of making ubiquitous. You're already coming. Come on in. Come on in. Come on in. I had my introduction and then asked for people to ask to come in, but that's fine. That's fine. Let me read it anyway. Ramin has a. Might as well sit down. My introduction was Ramin has a critical role in advanced micro devices, AI group, and GPA technology, positioning the company as a serious contender to NVIDIA. So the work is cut out for you. Ramin's insights are invaluable as we discuss AMD's strategies and potentials to challenge NVIDIA's dominance. Please join me in welcoming Ramin Rohani to the stage.
Thank you.
Now, for the video, I think I need to do some sort of a re-entering and saying, well, Ramin, thank you very much for coming to our program. You've been at AMD for 2.5 years, but considering that you worked at Xilinx, your tenure at AMD expanded actually when AMD bought Xilinx. So you've been there for 14 years. You're a veteran of the EDA and have worked at chip architecture companies for more than 2 decades. But before we dive into that, let's talk about your background. Where were you born? Where were you raised? What did you do in your youth?
So it's really strange. I was born in Tehran,
Uh-huh.
but I was born with a French accent.
How so? Your doctor was French?
Yeah, because my father had done a PhD in France before I was born, and my older brother and sister were born in France, so they didn't speak Farsi until they were a few years old. Then they went back to Iran. I was born there. Everybody was speaking French. I went to Razi, which was a French school, and then eventually, before the revolution, we went to France, and I basically never spoke Farsi again until I met my wife in the US.
And your wife is Iranian?
Yes.
Okay, and your Farsi, your Persian is better right now?
It's better. I mean, she speaks proper Farsi. I speak like 8 years old Farsi.
Oh, okay. Let me get to the parts which are the interesting question in the interest of time. You did not attend Sharif University because you left Iran.
That's right. I studied in France.
Had you been in Iran, you probably did. But you went to its equivalent in France, normal soup at Grenoble, which is similar rank, essentially. Unfortunately, they don't have a concours, so we can't ask you about your ranking on concours. But what made you become an engineer, and when did you realize that you have a passion for hardware design?
It was more software for me, but I studied EE and CS, and I ended up at Synopsys in EDA, like Rubil. And when you're in EDA, you're basically building CAD tools for chip designers.
Yes.
So you have a foot in both software and hardware. So some of them fall on the silicon side, like Rubil, and I fell more on the software side. But I kept on going back and forth to hardware and software company. When I realized I wanted to be an engineer, I guess it was in the early 1980s with the first personal computers. I got one. It was like a 1 megahertz computer with 48 kilobytes of RAM,
yes.
which part of it was used by the OS. And that's when I realized I loved that thing. I was 12 years old. I was just programming night and days, monopolizing the family TV because that was my monitor.
Well, yes.
And saving my program.
What brand
on
of computer
audio
was it?
tapes.
what brand of computer was it? An Apple II?
Oh,
because I had one of those.
You know, it was the same processor as Apple. It was a 6502, but you won't know it. It was a British brand. It was called Auric.
Okay.
Auric Atmos.
Yeah, you're right. I don't know it. So with that love, you went to Ansimag and you got your master's over there.
That's right.
How was that experience different from getting a master's in the United States, do you think? Is it harder?
How is it different? First, it's free.
Okay. That makes it easier, yeah.
And harder, I don't know. I didn't really study in the US, but...
Have you compared yourself and your knowledge with engineers who go to, colleges over here? Actually, when you went to Berkeley for your, studies and doing some EDA over there, did you realize, do you know more than the fellow students that you were over there?
I think in the US, maybe in high school, they don't study as advanced science as in Europe, but they do catch up in university. Because when you get to university in Europe, you're kind of exhausted because they put so much in your head.
Especially with baccalaureate.
Exactly.
Yeah.
So you want to let go a little bit of the pedal. In the US, it's the contrary. When they get to university, they're so fresh, and that's when they learn a lot. And at the end, they're very strong. They're very, very strong in the US when they come out of universities.
Excellent. Now, at AMD, you are at the helm of AI innovation. At times that NVIDIA is enjoying dominance, not in AI hardware and its support software, but also in market recognition and adaptation. This is a very challenging position for you, with huge rewards for AMD and you, if and when you succeed. And to be sure, there are some huge challenges. Let's go through some of these challenges. One of them is technological. What are the key technological advancements that AMD is focusing on to compete with NVIDIA at the AI hardware market?
Yeah. So technology-wise, I do believe we actually have a better hardware than NVIDIA.
They all say so.
The problem is what Rubil mentioned. One, it's when you use it at scale, it's reliability, and the other one is software. But it is better just if you look at the specs, right? Because for something like generative AI, like ChatGPT, all that matters is how much memory and how much memory bandwidth you have in your chip, and that's with HBM memory, high bandwidth memory. And we have significantly more HBM memory than NVIDIA H100.
Give us some number.
So we have 192 gigabytes, and H100 has 80 gigabytes, so we're 2.5 times more. But the bandwidth is what's also important. We have maybe 1.5x higher bandwidth. But that means if you take a 70 billion, Llama 70 billion model, it fits in one of our GPU. You would need 2 H100 GPU. And it's going to be the same with GPT-4 and all that. By the way, Microsoft did deploy our GPU for GPT-4. That was announced by Satya Nadella at Microsoft Build just a couple months ago. And he did say we have the best TCO because they need half the GPUs to infer. Now, why don't we make $50 billion a year? Because NVIDIA makes 100. That's what he said. It's software and reliability.
So where is AMD investing in its R&D resources, and how does it plan to differentiate this product from NVIDIA offering? Where are you spending your money?
So hardware is one, obviously. So how come we can put 2.5 times more HBM than NVIDIA? That's because of the technology AMD has, which we used to beat Intel basically at CPUs. I'm not sure people realize, but AMD's market capitalization is higher than Intel's. Of course, NVIDIA's market capitalization is higher than Intel plus AMD plus Qualcomm plus a bunch of other companies.
That's just the stock prices. Yes.
But that technology that we have includes basically chipletization of big chips. Yeah. So that's what NVIDIA did with their next generation. But in our current GPU, we have 4 chiplets. So the package is huge. We have 4 chiplets, and on the best part is that they're on top of another chip. So it's 3D. Yeah. And the top is multiple chiplets. And so the fact that it's 3D means we can pack a lot more logic, and we have a lot more room to put HBM memory. That's why we have this advantage. Now, NVIDIA went into chiplets, and maybe in the future they will go on 3D as well. So they'll get the same technology there.
But you have the advantage there. How about the software ecosystem to support AI development?
So that's the big piece. And I have to say, right now, as we're talking, you would take any AI model of Hugging Face, it will 100% run on our GPU. Stable Diffusion came up with Stable Diffusion 3.0 like a few weeks ago. They ran it on our GPU, it just ran out of the box. So everything runs. The problem is, does it run at the highest possible performance? And that's why when we talk about CUDA, software, NVIDIA has so many software developers, the real issue is how do you run at high performance? So AI is basically about doing massive matrix multiplies that will never fit in the GPU memory. So the question is, how do you slice those big matrices into tiny little matrices and do tiny little matrix multiply and put everything together so that you use your silicon very efficiently? Like 90% of the time, for example, it should be doing multiplications, right? So if a startup like a Samba Nova or someone does a hardware that's far better than AMD and far better than NVIDIA, but they're at 10% efficiency to do those matrix multiply, they're not going to survive. And that's what's going on. All these startups are coming, they're doing this great hardware, far better than any of us could do, but 10% efficiency, so they die. And Google, their TPU, by the way, it's not just Google, AWS also have their own chip. It's called Inferentia for inference and Trainium for training. And Microsoft just did theirs, Meta just did theirs. They have great hardware and great efficiencies for their own internal workload, and it's terrible for general purpose AI workload. Yeah.
So another issue you already mentioned, the one with Intel, is partnership and collaboration. Can you elaborate on any of the recent or upcoming partnership or collaborations that AMD has established to bolster its position in the market, in the AI market?
Sure. One of them was Hugging Face. So we partnered with them a year ago now, and we basically gave them some GPUs, and they're running continuous integration and continuous development on our GPU. So any new model that comes on Hugging Face, but Hugging Face is a massive repository of 750,000 different AI models, most of them generative AI model. So whenever a new model comes in, they try it on our software, on our hardware. Whenever we come up with a new software, they try it and they tell us all the issues and we fix them immediately. So that guarantees that we always have day zero support for any new model. And we work with other companies like VLLM, for example. VLLM is a open source company from Berkeley to infer large language models. Other companies like Llama Index to build pipelines like agentic pipelines with multiple LLMs and so on.
Which one of these do you think is going to be so significant that's going to help you in your battle against NVIDIA?
Hugging Face for sure. I mean, it's a tiny little startup that's worth now probably $4 billion. Everybody uses them, so everybody uses them. And then, of course, our partnership with the big guys, right, Microsoft and OpenAI. We've been actually working with them night and day for the past year to get to that launch of inferring GPT-4 on our GPU.
That's the big prize for you.
So yeah, the ones that help are obviously our partnership with the big hyperscalers like Microsoft, Google, and so on, and then with Hugging Face, definitely.
And how do you feel about that? Do you think you can contend successfully? Obviously, otherwise they wouldn't do it.
Yeah. As I said, right now our software runs everything, and in terms of efficiency, we got there with GPT-4, we got there with the Llamas, we're getting there with the Mistrals and the QN from Alibaba. So it takes writing a lot of optimized libraries to get to high efficiency. And NVIDIA wrote maybe thousands of optimized libraries and still writing a lot. They have a lot of software developers. So we need to do that, and we need to raise the ecosystem to do that with us as well in order to catch up.
Another issue for you is, in the market strategy that you should have is generative or general purpose GPU has to be good not only at one segment, not only at machine learning. You have to be good at AI hardware market, from data centers to edge computing and all that. So what's your strategy to be able to be so flexible yet so efficient that you satisfy both ends of these constraints?
So first, I don't know if people realize that, but AMD GPUs are actually the top GPUs in the world for HPC workload, high performance computing. Yes. Those are scientific workloads for like climate research, health science, and so on. So the biggest, the number one supercomputer in the world on the top 500 list is AMD supercomputer with AMD CPUs and GPUs. It's called Frontier. It's one of the national labs are using that. It has one exaflop, that's 10 to the power 18.
Yes.
So a billion 64-bit operation per second. When we're talking about AI, we're talking 16-bit, 8-bit, 4-bit. That's a billion 64-bit operation per second. And it's been #1 on the top 500 list for the past year and a half. And we're going to come up with a new one by the end of the year that's probably be twice as powerful. And so we have leadership there for HPC. And now we're starting to have leadership technology-wise in AI as well. But obviously, there's a lot of work to be done there. And NVIDIA comes up with new products extremely quickly. So that's also a challenge. When we announced our GPU with a lot more HBM compared to H100, they came up with H200. That's going to come out this year, which increases the amount of HBM. So that's going to come out before Blackwell as a response. So now we have to respond.
They are working hard. Two issues before we get to the questions of people. One of them is power. How does that play into your plans? Is there any global power shortage or deficiencies we're going to have because of AI and all these needs for AI? Or is there a local concern with power that it's limiting some of the work that you can do? But the second one is kind of obvious, but the first.
So clearly, hyperscalers like Microsoft, Google, AWS, and so on, they have two problems in their lives right now, only two. One is space, and the other one is power. Space and power. To put more compute, more GPUs and more CPUs in their data center. And so yes, it is important to optimize for power. So when we do new systems, NVIDIA or AMD, when we do new systems, they typically use more power, but for 2 or 4 or 10 times more computation performance. So you're actually helping the problem. Yes. So you take, like, let's say a room full of computers, like this room, and you turn it into a quarter of the room with maybe half the power and the same performance. But if you look at the individual GPUs and CPUs, they take more power than the previous CPUs and GPUs. But because they're so much more performant, you're actually using less space and less power for the same compute. So we're doing that, and it's exponential, NVIDIA and AMD. The performance per watt is going down more than 2x every 2 years, more than 2x every year and a half. So it's going down more than Moore's law. Yeah. It's very significant. Of course, the goal would be maybe in a few decades to do something like a GPT-7 or GPT-8 in 25 watts, which is how much power our brain uses, right? Right now, it's several kilowatts.
And that would be with quantum computing, perhaps.
Maybe not. Maybe we can get there differently.
Well, yeah.
And in terms of supplying power, now hyperscalers are talking about building small nuclear powers, like mini nuclear power, locally, just
no
to power their data
line,
centers.
Yes.
Yep.
Excellent. Okay, lastly, the topic that you raised in our earlier conversation about should we be afraid of AI? And your short answer was no, and you promised to expand on it today.
Yeah. So I'm not afraid of AI at all.
We're afraid, yes.
The thing is, every time there is a new step function in technological innovation, people are afraid. It was the case for airplanes, for trains, for cars, for fire, I'm sure. We weren't there to check, but
this is going to be just the same normal thing. This
I
reminds
think so.
me of
I
this,
think so.
Of this guy who is feeding this bird every day, and the bird thinks everything is fine every day until Thanksgiving.
Until he eats the bird, yeah.
So we're okay because everything has been okay in the past.
I think it's going to be okay because technology has been always there to improve our productivity, and this is no different. It just improves human productivity. So now, yes, this is a technology that will eventually have, maybe in 10, 20 years, eventually have a general intelligence that outperforms human intelligence in
smart
completely,
outdo,
which is not the case today, right? Today, we cannot build a robot with ChatGPT in its brain and just 2 cameras and tell the robot, okay, I'm going to teach you how to drive a car today, and tomorrow you can drive a car. Right? You can do that with a 16-year-old human. You cannot do it with a robot, even with the most powerful AI in its brain, with, again, just 2 cameras for 2 eyes.
So we have a few years.
So
maybe?
we have a few years before we get to real intelligence, like learning new tricks. But when we get there, it's going to get 2x more intelligent a year and a half later, and 2x again, and 2x again. So it will become 10 times more intelligent than human, 100 times, 1 billion times more intelligent than human over time. It will happen.
We shouldn't worry about that.
I'm still not afraid, because I think we're going to use that to improve our lives. And we have examples, right? We have done that. We even at Xilinx, the company I was at, that AMD hired, we were doing tiny little chips that were also accelerating AI. And we used that with CERN, and they used that to actually discover the Higgs boson. We used that with Illumina to do very rapid genome analytics of newborn babies who are born sick, to find the cause of their disease, literally saving babies' lives. We're doing space exploration. We have a Xilinx chip on the rover, the self-driving rover on Mars. So we've been using AI for a lot of good for humanity, and I don't think it will change just because it's 1 billion times more intelligent than us.
Well, with that optimism, which I really like, and I hope it lasts, I would like to open the floor for your questions. We have Ali over here. Can we have the mic, please? Or should I use my mic? Omid? It's coming? Okay. Ali over here.
Thank you. My name is Ali Rostami. It's been a while as for the affiliation that I've been working on an idea of mine. In a stealth mode, really doesn't have anything to say about right now. What I can say is it needs consumer-grade hardware, right? So that's the way that I see it. It's an
What's your question, Ali?
It's an immediate market, right, that you can enter that NVIDIA is not. So can you tell us like a little bit about what's the plan? Do you want to like catch these segments of market?
So NVIDIA's customers are actually looking for an alternative, and they're also looking for more supply. So right now, we're very happy to fill that gap. We are looking at other market, but really right now the demand is so high for generative AI that we're very happy in that market.
The lady over here.
Hi, merci beaucoup. C'était un plaisir de vous rencontrer. And my name is Sarv Noderzad. I'm from Comet. I'm a market analyst in semiconductor industry. It's interesting that you brought up the market cap, because I was always thinking NVIDIA is stealing it from all of us, and not, I mean, the attention. But I'm glad that we have them, because now you know, say semiconductor, and they're like, oh, NVIDIA. So I want to ask you, why do you think the rest of the ecosystem, because the efficiency that you talked about, it's you know, it's not possible with the companies like TSMC on the manufacturing side, and the delegation that goes in the art of building these chips. So why do you think the rest of the ecosystem is not getting the attention compared to, you know, this side of the industry? That's my question. Thank you.
The rest of the ecosystem, as of TSMC,
TSMCs, as RF subsystem suppliers, yes.
I think they are. Like, if you look at the Supermicro stock, for example, I think they went up faster than NVIDIA did by selling NVIDIA servers. So look at Supermicro, Dell, it's happening a little with them too. Even TSMC is doing okay. And if you look at EDA companies that we both use to build those chips, Synopsys and Cadence, look at them. They're growing really, really, really nicely as well. They're on an exponential path. I think NVIDIA is really creating value for everyone, for themselves, for us, but really for Supermicro, for Dell, for Synopsys, Cadence, TSMC. I think it's happening. I think it's happening.
Reza up front.
Hi, my name is Reza Faribar, software engineer, also faculty. So question, obviously you guys are talking about competition between AMD and NVIDIA and Intel and possibly Google. What do you think about China? And also, I guess related to this, do you think total reliance on TSMC in Taiwan is going to be like a weak link going forward?
Yeah, that's a very good question. So the Chinese hyperscalers like Alibaba, they also have their own AI chip, like the Google TPU, but they're also buy a lot of GPUs from NVIDIA and AMD. They have probably the same problem as Google. What they built is very specific for one workload, but they need a lot more AI workloads. They have search and recommendations and LLMs and all kind of workload that they need GPUs for. So we don't see them there yet. There may be like Google maybe for the TPU, but they still consume a lot more GPUs than they have. Relying on TSMC is very risky, yes. It's very risky. If China invades TSMC tomorrow, it's going to be a disaster in market cap. So TSMC is building now a fab in the US. Obviously, Intel got an awful lot of money to ramp up their fab and their technology, which is behind TSMC. And their fabs being built in Europe as well. So the industry is rapidly building fabs outside of that region. Because the risk is very high indeed.
May I cut in for just a quick follow-up after Reza's? Do you think the fact that China also depends on NVIDIA and AMD's chips and others is a deterrent for China not to disrupt TSMC's work for the United States?
Oh, absolutely, because
they're going to be in trouble.
Yeah. TSMC promised China that the day they invade, they're going to self-destruct. Yeah. They're gonna self-destruct the factory. So
nobody
it's gonna be a disaster for China as well.
Yeah, thank you. Rubil. Yes.
What?
Thank you.
Your background from Xilinx, right? What Xilinx used to do and is doing regarding the AI? I'm pretty sure like you are in edge computing and all those stuff. The good stuff that you said, you put on the Mars and all the stuff. I'm interested to know what's happening on the FPGA side for AI.
Yeah. That's actually quite fun. We are in edge computing. We're in self-driving cars and medical equipment and things like that. For example, Subaru has one of the best front camera. They're kind of a benchmark in the industry for smart cameras. We're in Subaru. We were in EyeSight 4. We're going to be in EyeSight 5. EyeSight 4 was more computer vision based. EyeSight 5 is more deep learning based. So we're going to be the chip powering EyeSight 5. It's SoC. It's really an SoC. So it has a system on a chip. So it has an ARM subsystem. It has an FPGA, and it has an AI accelerator, which we call the AI engine. It's not a GPU. It's an invention from Xilinx. Yeah.
And the last question goes to the gentleman over there.
I think the NVIDIA guy read my mind. He's using a GPU probably. I have the same kind of question along the same lines as, what do you see a real merit in developing AI over FPGAs going forward with especially AMD acquiring Xilinx technology?
Yeah, that's a good question. At Xilinx we build a special hardware we call the AI engine, which is kind of a mixture between a GPU and a DSP processor and an FPGA, but it's extremely dense in multiply accumulate, much more than what you can do on a regular FPGA. So I think it's hard to beat that with a regular FPGA. It doesn't have the compute density you need when you need a lot of multiply per second.
So you think AMD will continue investing in that area?
We
in
will continue
FPGAs?
invest, yeah, because we have the AI engine. We will continue invest. So it's an SoC that has a little bit of FPGA, a big AI engine, and then a ARM core. We'll absolutely continue to invest. That's what's going to go in Subaru eyesight. Yeah, so we will absolutely continue to invest there. But pure FPGA with nothing on the side to accelerate AI is going to get harder.
Okay,
Well,
thank you.
Well, thank you very much. On behalf of the Ahmadi Group, the Plug and Play, Persian Tech Network, and the Iranian community, I thank you, Mr. Rohani, for coming and spending time with us and answering our questions.
Thanks, Said.
Well, thank you very much. That concludes the formal part of our presentations. The presenters, the speakers are going to spend a few minutes over here, and you can ask your follow-up questions. Check our site for the future, because we know we changed from Tuesday to Thursday. Hopefully, we'll go back to Tuesdays more regular. And do subscribe to this, wherever it takes you, as well as the YouTube channel for Persian Tech Network. Thank you very much. Have a good evening.